Hello my friends! We continue our videos about VOACAP online ham radio predictional tool. In the last video, Jari, the creator of this tool, explained us many reasons how we can use it. And now we will go to the most important thing, how to use it, how to use the interface of VOACAP. Hope it will be interesting. Let's start. Hello, Jari.
Hello.
I'm looking forward to know more about ham radio online prediction tools, VOACAP, and I hope that today we can continue our job.
Yes, absolutely, absolutely. Now we are getting a little bit, deeper into the service, more details, and let's see what we can do.
Yes, Jari, I have a very good friend, Indy from Australia, and his call sign is Victor Kilo 2 X-ray Bravo, and I would really like to have a SKED with him. Could we look at this example and to know if it's possible or not?
So the first thing is, of course, that we need to know what kind of a system your friend has, so that we can set up the right parameters into the VOACAP. So if you can a little bit, tell me what kind of antennas and the power and stuff like that.
Yes, the problem is that he has no big power and a big antenna, because he is a track driver. And his antenna is codon 9350. It works all bands, and the power is only 7 watts, 70 watts.
70 watts.
70 watts, yes.
Okay.
How do you think it's possible?
Yeah, I think, we can see if it's possible. So let's see. Let's see what we can do.
First of all, Jari, could you please explain about these different colors, cycles in the center of program? Red, green, and blue one.
Oh, these one. Okay, yes, definitely. So these actually are related to the red marker, to the blue marker, and then they are also related to this small blue circle in the middle of the circuit. So these blue circles here, is the midpoint of the distance between the transmitter and the receiver. And also we have the long path, which is this red dotted line. And here also we have, this blue circle, which is the midpoint of the long path circuit. And basically what this does, it shows you very quickly when the sun is rising, when the sun is setting at that particular point. So if we have, this red marker, so if I click here, this is sunrise. So it shows you the terminator at the sunrise hour at the red marker. And if you click here in the middle, it's sunset. So this is the sunset point. And you can see the exact UTC time here in the bottom left corner. 1853 is the sunset. And if I click again, the sunrise, so it's 1009.
Great.
And then this third one, it's the midnight hour of this red marker. So it's 22:01 UTC. And the same applies to the receive side here in the map. So here I click, the first one, the sunrise, and the middle one, sunset, and then the right one is the midnight hour. And here we have, in the middle, we have the short part midpoint, and this lower one is the long path midpoint. So if I click here, it's now we are talking about this midpoint circle. So here the left one is the sunrise and the sunset, and then the midnight. And the same for the red one. So here now we are talking about this point here over Australia. So this is the sunrise, and now it's the sunset and midnight of this particular point. So this is something that is useful when we are talking about low band predictions, because if we are talking about 80 meters, 160 meters, and so forth, so VOACAP is not that great on the lower band. So I have created this tool to show you the day and night terminator and the areas of day and night. So, and with these circles here in the top of the map, so you can see the most critical I mean critical, but the most interesting hours for low band DXing. So this is the purpose of these.
Please, could you explain what the main role about midpoint? Why we need to know about midpoint?
Well, there are some cases where it's good to know where the midpoint is. So as you can see, so because of the map we are using, so you can see that the midpoint is not in the middle of this circuit; it's a little bit lower. And when we are talking about low band DXing, so if let's say that the sun has already risen in your QTH, but it's still most of the let's see, let me slide this slider. This is a kind of a UTC slider, so you can see what hour it is and what is the terminator. What does the terminator look like? So here, for instance, let's take this kind of setup. So the sun has risen, has already up in your QTH, but we can see that the sun is not up in the midpoint and not up in the receive side. So you can say that this is still a kind of a time period where you can work low bands. But as soon as the sun reaches the midpoint and it's over the midpoint, so by experience we know that then it is becoming harder and harder to keep QSOs on low bands whenever we reach the midpoint. This is a kind of a experience that I have. Other people may have different experience.
Okay. Thank you very much for your explanation. Let's start with India.
Yeah, the Indy. So where is he located, by the way? Let's start with that.
His locator is Quebec Foxtrot 35 Echo Alpha Radio. Quebec Foxtrot 35 Alpha Radio.
Okay, so I enter that locator in this area here, and then I only hit the tabulator. So it calculates the latitude and longitude for that area. So for that Maidenhead locator, so we can see these actually there. And I can also show you another feature in VOACAP map. So there's this no M. M means Maidenhead locator grid. So if I click here, so then I can see all the locators, and we can definitely see that this Quebec Foxtrot 35 Alpha Radio. So this point is in the middle of that specific grid. So I think it will also help, if you don't know, exactly where to put. So if it's somewhere, so you can choose your coordinate within that grid as well, if you want to do that. But if you put the grid here, so it will always be in the mid area of that grid, in the middle of that grid. All right, but let's go back. So it will be alpha radio. Let me just set it back, so like that. All right, so let's let me hide this. So I click, you know, this M again, so it will hide, you know, this grid. And then we have, so which mode? Let's start with SSB, as you said again. So, and then we select the power. It's 70 watts. So let's choose 100 watts. It's a little bit more than you know, he has, but then let's use that. And then we have antennas. And
Jari, I'm very sorry for interrupt you, but in this area we should choose my power, the power of transmitter, or of the power for receiver.
I think, you know, in this case, if you want to keep a contact with him, so so let's do it that way, that I will show you how you can switch so that it will be actually, the transmitter will be his QTH. So now we are selecting 100 watts and the receive side is here, but we will now make a switch because you have 1500 watts, so you have the bigger power. So let's do so that you know, in this QTH is actually transmitter side, and how you can do that. So let me a little bit, you know, zoom out the map so we can see that your marker, the transmitter marker, is now red and his is blue. But if you double click the blue marker, you can change the roles. Now he is the transmitter and you are the receiver. So double clicking the blue marker, you can switch the roles of receiver and transmitter. And then we you know, set up the antennas again. So now he has this multi-band vertical, and we can see that earlier we had used, you know, this is your setup as transmitter, but we can also switch the transmitter receiver antenna. So now we do that. So now your setup is here in the receiver side and his setup is here on the upper section. And now we have to select the correct antennas. Okay, so let's click antennas away and then we go to settings. And now again, the critical is this sunspot number. So for May, I think, you know, it's something like 50 or something, but lately it's, you know, sunspots have been really high for several days. So let's do so that we limit, you know, we use our own sunspot number. Let's use sunspot number 90. So this is our own manually selected sunspot number, and you can select any number between 0 and 300. And otherwise, we don't have to use the other you know, input values. We don't have to change anything. They are all good. So now we can use, you know, the propagation wheel as we did last time. So it's this wheel. We can see what would be the most perfect times for a QSO. And now we can see that this is a challenging circuit. So let's see what we can get. So the darker the color, the better. So we can see there is a little bit, you know, darker green. So what is this? It's 8 UTC to 10 UTC on 10 meters. But, you know, as you can see, the probability is around 20%. So we can see that there are some times on the upper bands that we can expect some good chances, but we have to do a deeper analysis. And now I can introduce you know, the charts that we didn't discuss last time. So we have also these propagation charts. So let's remember that we have 8 to 10 hours. So it's 10 meters and 12 meters and 15 meters and 17 meters. These are the most probable bands. at different hours, of course. But let's take a deeper look at the charts. So I click Propagation Charts here, and then what we have here. So we have, this reliability, which is this probability. Reliability, or REL, that's VOACAP speak. It's a probability percentage. SDBW, that's also something that VOACAP uses. It means signal strength. The value that you can see in your S-meter. So that's SDBW. MUFD, that's about, is our frequency below the predicted maximum usable frequency. That's another VOACAP parameter. So we are not talking about this. But we want to know more about the conditions on the specific band. So let's first select 10 meters. So let's see how it looks. So we said that it was around 8 to 10 or 11. And here we can see that what we can see, first of all, here, let's talk about, these colors. So everything that is LP, that's long path. So we are not interested in those. So let's just click, those colors here. So they will disappear from our chart. So what we have SDBW, which is the signal strength, that value that you can see in your S-meter. So you can see here that it is pretty low. It's minus 158 and so forth. What does it mean on the signal, on the S-meter? So you can see here, it's close to S0. So it's almost in the noise. And that is not actually really good. This is the signal strength, but the reliability, you can see the reliability is like 20%, as we saw from the prediction wheel. 20%. Okay, that sounds really good, but the signal itself, seems to be really close to noise. So it can be really hard to keep that contact. At least it is not, at least you are not talking so much. Maybe you can exchange reports, but that's basically it. So it is close to noise. So let's see what happens on 12 meters. It seems to be a little better. Let me also here take away, the long path related lines. So here you can see it's peaking at 9 p.m., 9 UTC, and the reliability is 26% at 9 o'clock. And this is a little bit better. As you can see, it's S1, so maybe this could work, but it's still, very close to noise. Maybe if I would be you, so I would try to begin with. I would try, this 5 UTC. It's not exceedingly good, but this would be a good start, to try this, 5 UTC on 17 meters. That would be basically it. And here we see that if we go to 20 meters, so then also we can see that the best values will be in the night time. So basically we can see there's a dip at 20 hours UTC. So let's see, what does that mean? 20 hours UTC, it's it's close to his sunrise. So there is a kind of phenomenon called pre-dawn dip. So the signals are decreasing just before the sunrise, and then they just can increase again, and we can see this phenomenon here.
Green line? Is it green line?
No, it's a this is crane line, but pre-dawn dip. So this is something that when it's close to sunrise, so the signal strength, they can go down just before that time of the day.
Yes, I see that it is a big challenge for us with Indy. Maybe there are some other opportunities, or what about the space weather? Could you explain something about it?
I would say that if the space weather is disturbed, so then your chances will be less. So I would look for, you know, a period when the sunspot number will be high, but the space weather will be calm. That would be my you know, best you know, recommendation.
It was very interesting, and I understood that it will be a big challenge, and
Indeed.
I will be just more happy when it will happen.
Absolutely.
With the QSO. Jari, thank you so much for your explanation. If you have any questions, please put them in the comments, and Jari will answer for them. It is a unique chance to have answers from the creator.
Yeah, I will try to answer them. So we pick only questions that we can answer, right?
Right. Okay, Jari, thank you so much, and see you next time.
See you, Raisa. Thank you so much. Talk to you. Bye-bye.
I'm absolutely impressed how it works, and I see that the QSO with my friend Indy from Australia will be a big challenge for us. I remind you also that the link to our first video in the description, and the link on the VOACAP tool is also there. Bye for now, 73 and 88.